You already know how to solve systems of equations. In fact, you know several different methods for doing it. You've solved for 2 variables and sometimes for 3 variables. But the equations have always been linear, first degree. Now the time has come. We're going to look at systems containing squares. For example, in this system of 2 equations, we have one linear equation and one quadratic equation. As usual, solve means find values for x and y that make both equations true. And that's just what we're about to do. We'll do that by using the substitution method we learned earlier. If you've forgotten how it works, you might want to check out the review module on substitution. You'll also need to remember the steps involved in solving by elimination. If you're in doubt about either of these methods, stop and take a look. Now, the problem. Where do we start? Let's take that first equation and solve for x. What we're doing is picking out the letter which looks easiest. Here it's x. Here's the expression we find for x, and immediately we substitute it into the other equation. We substitute it into the quadratic equation, the one with x squared and y squared. But as soon as we substitute, no more x squared, just a simple quadratic equation in y. And we know we can solve that. We take that bracket and multiply it out, and then collect terms. And from there on, it should look awfully familiar. If you need to review how to solve quadratic equations, take a look at one of these modules. And just to prove we can do it, let's go all the way with this problem. The expression doesn't factor, so we'll have to use the quadratic formula. You probably have it memorized by now. You should for your own sake, but look it up if you have to. And you'll find the substitutions for A, B, and C in the formula look like this. As usual, we can simplify the square roots and remove a common factor of 2. That gives us 2 possible values for y. Great, but something is missing here. We have 2 values for y, but we have no values for x. Where do we get those? From our substitution formula, the one we used at the beginning of the problem. That gives us more algebra to simplify. And watch this closely. That minus sign outside the bracket does something strange to the plus or minus inside. It changes its order. This is important because it tells us that in the 2 points making up our answer, the plus sign in x goes along with the minus sign in y, and minus for x goes along with plus for y. And that's it. We've done it. Well, there was a lot of algebra to simplify there, but we really copied our substitution method very closely. Now here's one for you to try. Come back as soon as you have your answer. First of all, I take the second equation and solve it for x. Then I substitute that x value back into the first equation, the quadratic equation. By doing that, it turns out that I get a nice simple equation for y. My two answers are +2 and -2. Then I substitute each of those two values into the other equation, where x equals a -2 times y. Since y is a plus or -2, x must be a negative or positive 4. Positive when y is negative, negative when y is positive. And that gives me my 2 points. So we've found 2 points. Big deal. Anything else? Well, you might remember that when we did this before with 2 linear equations, we got the intersection point of 2 straight lines. But this time there's more. Look at that first equation. It's not a straight line. It's an ellipse. And the second equation is a straight line. So what we found here is the 2 points where our straight line crosses the ellipse. That kind of thing can be very useful. And if you've forgotten all about ellipses, hyperbolas, and the like, once again you'll find there are review modules ready and waiting to help you. Now, what about a system like this? A little different from the others. This time, both equations are quadratic. Do you recognize them? The first one is a hyperbola, and the second is an ellipse. So when we solve them together for the intersection points, we'll expect to find 4 different points, 4 sets of x and y values. We decide to try substitution again. We look for a nice, easy letter to solve first. We don't find one. They're all messy. So we decide not to use substitution. We'll use elimination instead. I see a 2x squared and a 3x squared, so the LCD of the x squared coefficients is 6. So I want to multiply the first equation by 3 and the second one by 2, which makes the 2x squared terms the same, exactly what I had in mind. So now I can subtract them to leave y by itself, the same process we used with elimination in linear equations. All of which tells us that y equals positive or negative 1. And now that we have y, we can find the value of x by substituting the y values into one of our 2 equations, either one, it doesn't matter, and then solving for x. 2x squared equals 8, so x squared is 4, and x will be 2 and negative 2. Now we've got 2 values for x and 2 values for y. We can combine them to form the 4 points we were expecting. We take each of the 2 values for x together with each of the 2 values for y to find the 4 intersection points. As usual, substitution at the end is only a good idea if the numbers are easy to work with. And what if they aren't? Well, then you use elimination all over again to find the second letter. Originally, we eliminated x and found the value of y. See if you can take it from there and finish the problem without using substitution. Just eliminate y, find x, and you have it. Begin by finding the LCD of the y squared terms and multiplying to make them the same. Then solve for x. You already know what the answer should be. This time in the y terms I have a 3 and a 4, so the LCD is 12. That means I want to multiply the first equation by 4 and the second by 3, like this, which gives me a positive and a negative 12y squared. So to remove the y squared terms, I want to add. The y squared terms disappear. I solve for x and find exactly what we found before, positive and negative 2. If you want more information on quadratic systems and more problems to practice on, you'll find them in your textbook. Just use what you know, do one step at a time, and good luck.